Ready for me to get started? Okay. Happy to be here. So yeah, my name is Tom Williams. I'm from down the road at Mines. I'm a computer scientist and a cognitive scientist. I'm in our computer science professor there, department there. I was telling Brad beforehand that a good talk, the advice is a good talk should contain like one core key idea. And so, of course, I'm not doing that at all. And I'm going to use more of the spaghetti approach, where I'm going to throw a bunch of ideas out to you and see what you find interesting. The title of this is Secret Agents, and the core premise of this talk is thinking about as an organizing concept, the idea of robot agency, thinking about robot status as agents, the different ways in which we can talk about robot agency, and the different implications that has for robots. So first off, to start, just to establish some shared terminology, what is an agent? There are a lot of definitions of agency, a lot of very different definitions coming from, if you're coming from different fields, so sociology, anthropology, et cetera, all their own very different definitions of agency. In our lab, we use the definition from Three and Sanders, who specifically theorize agency in the context of AI. And Three and Sanders argue that an agent is something that is autonomous, that is, it can change its state without stimuli. It is interactive, that is, it can also change its state in response to stimuli, and it's adaptive, that is, it can change its own internal state transition rules. And critically, within their framework, an agent is something that appears to have these properties, that is, at a particular level of abstraction, from a particular person's perspective, it has these things. And what this means is that because it means something, sorry, so this definition means that something that doesn't seem to be an agent to us as technology developers may well be an agent for users, right? So just because we look behind the scenes at the inner workings and say, well, that's not really autonomous, based off of how we know it works, because we know, for example, it's Wizard of Oz, that doesn't mean the system isn't an agent for our users, and that has implications. So what leads people to view robots as agents? So in some cases, we've been arguing that it is how a robot performs the sense of having a self. So and I think this is particularly obvious when we talk about multi-robot contexts. So imagine you are on the street and you are accosted by three robots, Alex, Avery, and Adrian. So by these robots having names, you are sort of developing this mental model where you have three distinct individuals. And we might separately think about the minds of those individuals and the bodies of those individuals. But either way, this diagram shows a sort of a one-to-one mind-body relationship for these robots in a way that's very human-like. But of course, this isn't how it actually has to be. And in fact, if you actually encounter three robots on the street, if that's something that happens around here, I don't know, it's almost certainly not three distinct individuals behind the scenes. It's probably likely that those robots are networked together. They're probably sharing information with each other. They're probably controlled by a single cognitive architecture. And what this means is that this is a very different mental model of this group of robots. But which of these mental models we develop, it being a hive mind or it being a set of individuals, each with their own identity, their own mind, all comes down to how we design these systems, right? The different design cues we use can lead people to view them as individual agents or as a collective, and that's going to change where we choose to place our trust in these systems. It's going to choose how we choose to interact with them and so forth. Moreover, researchers, for example, Sam Rieg and Aaron Steinfeld and their group and their collaborators at Carnegie Mellon have been looking at a variety of different ways that robot mind and body and identity can have flexible relationships, especially in distributed systems. So for example, they've been looking at things like co-embodiment, where you have multiple minds in the single body. You're interacting with this robot, but you might be interacting in the same way that on your phone, you could imagine having multiple virtual assistants installed that you could talk to that are in that same phone. And we would hypothesize that, for example, the level of trust that you develop in those different identities could be different. And those are going to be different from the amount of trust that you're building in the body itself. Similarly, what this means then is that designers, by communicating these identities in different ways, can lead users to develop these different understandings of the social others in their environments that is going to change where people choose to place their trust in the environment. And so in recent work, we have been developing a new theory of trust where our hypothesis is that we need to be reasoning about mind and body separately when we think about robots, saying it doesn't really make sense to just ask, do we trust this robot? We need to ask specifically about the trust that's being developed in the body of that robot versus the mind of that robot, because there isn't necessarily a strict one-to-one connection between those things. So in this theory, our first commitment is that the notion of trustees needs to be deconstructed into different loci of trust, different places where trust can be allocated, like the body of the robot and the identity of the robot. But that we also need to be looking at the different types of trust. For example, the way that Bertram Mala or his collaborators look at trust in terms of capacity versus moral trust. So here we have sort of a 2x2 axis between where the trust is placed and the type of trust that's placed in that loci. Based off of these commitments, we've been testing a variety of different predictions in our empirical work. We would expect, for example, that different levels of trust might be built and lost in these different loci. Different robot identity performance strategies, that is, different ways of sort of performing, having a one-to-one mind-body connection, even if that's not what's actually the case behind the scenes, may affect how concrete or solidified the trust is in those different loci, or how much trust is built or lost in those different loci. And finally, that different types of trust affecting actions, so blameworthy and praiseworthy actions, for example, may differentially affect the concreteness of the trust built or lost in those loci. So recent work, for example, shows that there's, from moral psychology, shows that there's a strong asymmetry between blame and praise, where blame is much more nuanced than praise. We think a lot more about who we're going to blame than who we're going to praise. And so similarly, when robots take blameworthy actions, our hypothesis, and this is borne out in some of our data, is that when robots perform blameworthy actions, people think more about who they are blaming, and end up with more concrete concepts of where they should be allocating trust in the system. So this is all very theoretical. Why does this matter? Well, if users perceive robots as human-like agents that are autonomous, interactive, and adaptive in the way that people are, especially in a way where you have a one-to-one mind-body connection as opposed to perhaps a hive mind, then they will mentally reason about robots and try to interact with them in the same way they do humans. Okay, so that raises a question of how do people reason about other people? And so this is what we refer to as theory of mind. And psychologists argue that there's at least two types of theory of mind, which we can, regardless of sort of how much you agree with dual route theories of cognition, we can think about them in terms of dual route theories. So there's a sort of a system one or fast type of theory of mind, where we're very easily able to quickly reason without any effort about what we think other people are aware of in an environment. And we can much more, as a second way, we can much more slowly and deliberatively reason about what we think people believe about those things in the environment. So in this scenario, this white hat agent might be able to quickly reason about, like, is this other person aware of this folder they're holding? And maybe even some deeper, more cognitive status oriented information, like not just are they aware of it, but are they focusing on that? Is it activated for them? Is it just something they're familiar with? And this is something we would think they should be able to assess very quickly. And in some of our recent work, we've been looking at how robots can also perform this type of quick instinctive theory of mind modeling. Very, very simple, Bayesian filtering approaches, showing that even just using simple linguistic features, we're able to learn models of cognitive status estimation, that is estimating for certain objects in the environment, whether somebody else is focusing on it or whether it's activated to them or just familiar to them, just based on the way they talk about it or if they're talking about it at all, in a way that is just as effective as using the rules that we would find from the linguistics literature if we were to hard code in those linguistics insights. This is important because if we have an estimate of whether somebody is focusing on something or just thinking about something, or if something's familiar to somebody, it changes how we're going to communicate about that object. So here, for example, if the agent believes that the other agent is focusing on this object, this can allow him to say something like it, because while it is really ambiguous, if the other person's already focusing on it, you can sort of assume that they'll know what you're talking about. Whereas if it's not in focus, or if it's not activated, you might have to say something long and complicated like the folder I hold in my hand. And so similarly, we've been developing models for referential choice, where we use this model of cognitive status to allow robots to decide how to refer to objects in the environment, whether to say it or this or that, or so on. And we've shown that the cognitive status is in fact the single most informative feature in making this decision, which is nice. Finally, people don't just use cognitive status to decide how they are going to refer to things, but they also manipulate other people's cognitive states in order to make their own lives easier. So here, for example, if the robot, maybe it is a robot, I don't know. The person with the white hat might think, well, I don't want to say something long and complicated like the folder I hold in my hand, but I don't think the person is aware of this folder or thinking about it. So if I point to it though, and I see the other person sees where I'm pointing, then I can infer that it's activated, and then I can say something like this or this folder, rather than giving the long complicated expression. One note here, so I sort of manipulated your attention by pointing, but also by drawing this circle around this. And this is something that we've been using in some of our research in the context of augmented reality. So we've been looking at how robots can use augmented reality gestures in the same way that people point to things in order to pick out things in the environment. We think that this is a potentially really helpful modality for gesture. There are a lot of robots that we deal with, whether it is, I mean, this is a turtle bot, but if you're looking at, there are a lot of robots that don't have arms. If you have a drone, you're probably not going to mount an arm on the bottom of it just so that it can like point to things. That might not be feasible, right? But the idea here is if the people who are working with the drone or another armless robot are wearing an augmented reality headset, then the robot should be able to generate visualizations in the user's field of view that pick out objects the same way that a physical gesture would. And we've looked at things like circles. We've also looked at things like virtual arrows, and found that regardless of the level and type of cognitive load that people are under, this is a really effective communication mechanism. Here, for example, this task is an augmented reality, but you can see that this arrow is showing up under the thing the robot is wanting the person to manipulate as they're talking about it. We've also been looking at other types of visualizations that are a little bit more analogous to physical gestures. So looking at virtual arms reaching out and pointing in the environment. And one of the things we found that's really interesting is these different types of gestures are more or less effective for different purposes. So if you're using a virtual arrow that pops up over the thing you're talking about while you're talking about it, that's really effective from a task-oriented perspective. It leads to higher accuracy, reaction time. But if you have a virtual arm that's reaching out, there's a very small performance drop, but people perceive the robot as much more, well, anthropomorphic, because it has like an arm, right? People view it as more warm and competent. So sort of depending on whether you're trying to optimize for objective metrics or for more long-term sort of social metrics, different types of augmented reality gestures are more or less effective. So takeaways from this first part: people perceive robots as interactive autonomous agents, or interactive autonomous and adaptive, which makes them agents to them. Designers can manipulate people's mental representations of robot agents through different types of identity performance strategies. People also expect robots to reason about their mental states when they're using language. And robots can estimate people's mental states and use them to communicate with people in unique ways, and can also manipulate people's mental states through things like augmented reality and gesture. So in the next part of my talk, I want to argue that robots are moral agents. So Flaherty and Sanders, again, argue that moral agents are agents capable of moral action. So same definition of agency as before, and then just add on, and they're capable of morally consequential action. And robots are capable of morally consequential actions. This is true for, there's obviously physical risks to robots, but also if we're looking at domains like education or elder care, there are obviously emotional risks and other types of risks that come along with robots' persuasive capabilities. And so a hypothesis might be then that because robots are moral agents, users will expect them to follow human moral norms and take moral cues from them. And this could lead to unintentional negative moral influence. So to walk through the argument here, a robot whose response to an unethical command, for example, doesn't explicitly reject that command, may intentionally communicate it would be willing to perform an action in question, even if a robot's not actively condoning it. So if you ask me like, Tom, can you go punch Jim? And I say to you, do you mean Jim Jones or Jim Jackson? It shouldn't matter, right? Why am I asking you? Even I'm not explicitly saying I'm going to do this, but merely by asking that question, I'm sort of indirectly conveying that I would be willing to do this for one of them. Otherwise, why am I asking? And so the idea here is that robots, even with these very simple dialogue patterns, could mislead people about what they're actually willing to do or not. This could influence humans' beliefs about what moral norms apply in a context if robots are really viewed as community members or moral agents. And this could negatively impact people's own moral ecosystems. And this makes sense because a major tenet of modern behavioral ethics is that morality is dynamic and malleable. It changes from place to place, context to context, and over time. And technology mediates humans' perceptions and actions in ethically relevant ways. Technology literally changes the way we see the world in terms of what actions we view as even options for us to perform. And in fact, in some of our experiments, we've shown this justice, where people observing the robot being asked to perform a morally unambiguous action and giving a morally problematic clarification request led to people believing that the action being asked about was more likely to be permissible. So the robot was actually influencing what actions people thought were permissible in this context, even just through this sort of indirect condoning of actions. We didn't ask about punching people, but that's okay. And so we've been trying to address this in some of our work. For example, just developing architectural mechanisms to try to avoid this. So for example, when ambiguity is encountered, before asking for clarification, consider the permissibility of the different disambiguations. Spin up simulation environments where you say, well, if I interpret it this way and I perform that action, how would that turn out? And then choosing different responses based off whether all or some or none or one of these disambiguations is permissible. But of course, our goal shouldn't just, like, this is a pretty niche scenario, right? Our goal shouldn't just be robots avoiding miscommunication, especially like in these clarification dialogues. Rather, when robots receive immoral commands, regardless of whether or not they're ambiguous, we argue that they should be actively pushing back on those commands. And so, for example, and this was a best paper nominee at IROS this year, in the cognitive robotics category, the way we tell the students to put it on their CV is like top 6 out of 2,000 papers, but that's assuming that all the 2,000 submissions were like cognitive robotics papers. I don't know how many cognitive robotics papers they actually had, but it probably wasn't that many. Anyways, so this was by combining. So in this work, we are trying to enable robots to automatically reject inappropriate commands by combining together fundamentally different architectures. So in our lab, we use DIARC, which is responsible for the actual language understanding, language generation, and goal reasoning capabilities. We combine that with a system from our collaborator Hao Zhang's lab for doing context recognition. And then we use Neil Dunham's work on task planning to actually do the moral reasoning so that we're able to perform multi-step moral reasoning. So we're able to reason about, if you ask me to do this, what is the sequence of actions I'd have to do? And is there something along that chain of actions that would be inappropriate? And then reasoning about that contextually. In this context, would that be inappropriate? And using that to automatically reject inappropriate commands. However, like most previous work on machine ethics, this work that we do in that work is grounded entirely in a sort of a norm-based approach. It's grounded in a lot of robot ethics work is grounded in either utilitarianism or deontology, sort of traditional Western perspectives. And in some of our other work, we've been exploring the use of other moral frameworks like Confucian role ethics. How many people here have studied Confucian role ethics before? One, wow, that's 100% more hands than I normally receive. Very, very quick introduction to some central tenets of Confucian role ethics. So Confucian ethics in general it has a focus on self-reflection and self-cultivation. It has a focus on the roles we play in our relationships with others. It has a focus on ritual practice and the way that through practice we can try to cultivate our morality in terms of roles and relationships. And we argue that Confucian role ethics is actually a really good framework for robots. One, because there's this focus on well-defined social and relational structures, which is maybe a good fit for robots and plays well with frameworks from human-robot teaming that are already reasoning about these teammate-teammate roles. And there's a focus on moral self-cultivation and care for others, which we argue might be maybe more productive to explore than a solely autonomous individualistic approach that's traditionally more popular. So robot ethicists like my former advisor, Matthias Scholz, have argued that morally competent robots, if we're going to develop them, need systems of norms and ways to use those norms in the context of moral cognition, moral decision-making, and moral communication. And we've argued that for a role-based approach to robot ethics, we probably still need norms, but they need to be role-oriented. And in order to do that, we also need systems of roles and relationships and an understanding of how actions are beneficial or not with respect to those roles and relationships, and then ways of using those role-sensitive moral cognition, role-sensitive knowledge representations in the context of cognition, decision-making, and communication. The specific types of roles we've been looking at, if you go back to older Confucian work, older being much older than the computer science research literature, there's a focus on cardinal relationships, key relationships that occur again and again in our social relationships between humans. Now, in that work, the types of relationships they focus on are things like ruler, minister, father, son, husband, wife. Some of these that are maybe a little bit outdated and also robots are probably not going to be involved in. But we argue that this idea of focusing on the key, small number of key relationships that repeat throughout our social engagements is still productive. And so we've been thinking about the types of relationships that robots will actually be involved in. Owner, ownee, supervisor, subordinate, teammate, adept, novice, and then I guess a good old friend. And we've been looking at different ways of encoding those. So in some of our recent work that's under review, we've been looking at ways of performing automated moral reasoning and automatically generating moral responses that are grounded in these roles, and looking at the different contexts in which robots might be generating moral communication, whether it's remonstrating with others, accusing others, correcting others, and so forth. If you were using a traditional sort of norm-based approach, you might, when a robot is communicating about some moral decision, it might say something along the lines of, I can't do that because that would be stealing is wrong. Whereas our idea is using these role-based knowledge representations, we might instead generate something like, I can't do that because that wallet belongs to my friend Sean, and a good friend wouldn't do that, in a way that we hope would promote more reflection on the actual people involved, as opposed to just sort of like the at arm's length actions themselves. And in fact, what we found is that these role-based moral responses can be more effective in certain contexts. So specifically, when participants receive a robotic moral intervention, and then they perform a task where they can put that moral guidance into practice, the moral intervention will be more effective when it's highlighting these role-based principles. And this goes back to those key Confucian tenets of focusing on rituals and moral practice as a way of cultivating our moral selves and encouraging others to cultivate their moral selves in with attention to the roles we play in our relationships with others. We've also found in some of our work that these moral advising scenarios where robots are giving moral interventions are really interesting because they're fundamentally different from the paradigms of moral action that we typically see in HRI and robot ethics. So the sort of typical the stereotypical robot ethics scenario, right, is the trolley problem. I guess one of the typical just moral psychological patterns is the trolley problem. Do you pull the lever to save killing one person to save 5? And that's the typical robot ethics sort of dilemma that people in HRI have looked at. And recently, in conjunction with moral psychologists like Bertrand Mallah, we've been looking at moral advising. And one of the things we found is that while when you're looking at moral action, people have different preferences, or they blame differently for humans and robots, with different amounts of blame ascribed to action versus inaction for humans versus robots. When we're looking at advising, people prefer both humans and robots to recommend actions that maximize the greater good. So prefer both humans and robots to sort of pull the lever, or to recommend pulling the lever, killing the one person in order to save the 5, even if somebody actually performed that action, if a human actually performed that action, they would blame them more than if they hadn't done that. So the advice people give and what they actually want people to do is different. And so that's suggests that this sort of moral advising domain, we need to be studying in maybe in a different way than we've been studying moral actions. Of course, it's going to be a while before robots are going to have these types of robust reasoning communication capabilities. Not to say that like the technical work my students are doing isn't good, but like it's a little bit far future still in terms of actual deployability. So just as a very brief pitch for some of the stuff that we've been doing, actually collaboration with some of you folks. We've also been looking at some domains where we actually explicitly want to keep humans in the loop, potentially more consequential domains where there's real risks of, there are real risks that come with robots' persuasive power. Specifically, we've been working, including with some people who are on the call, to understand how therapists are using teleoperated robots. I think the reason, you might say, well, that seems like a non sequitur. But the reason why I actually bring this up here is because one of the things we've also found is that some of the tools and techniques we're using in that robot teleoperation work can actually help us more ethically design our autonomous robots as well. So some of the participatory design techniques, for example, that we've been using to understand how therapists are using these teleoperated robots and the interfaces that are being used in those the teleoperation interfaces that are being used in those works. We've also been using to understand how kids reason through some of the ethical concerns surrounding robots to great effect. And I would say more about that, but I never really know how to talk about work that's under review. I don't know exactly who in the room is going to be on the reviewing committee. Anyways, so the takeaways here are that people perceive robots as capable of moral action. This means they are moral actions, moral agents. People thus reason about their moral beliefs and moral actions into cues from inferred, observed, and communicated beliefs of those robots. And we're exploring context-sensitive, norm-based and role-based approaches to robot moral reasoning and moral communication. So third point, and this will be a little shorter. Robots are social agents. So again, using the same logic that Floridi and Sanders used about reasoning about robots' moral agency, we've been using to reason about social agency. I think social agency is one of these terms that gets thrown around the HRI research literature a lot, but people don't really define it. So we've been trying to, and so we're defining a social agent as an agent, same criteria, that is capable of social action. And to define social action, we've been relying on Brown and Levinson's politeness theory, arguing that social action is action that affirms or threatens a human's positive face, that is the self-image they try to promote to others, or their negative face, that is their sense of autonomy. So this allows this sort of a parallel structure where we've got this core central theory of agency. Moral agency, according to Flaherty and Sanders, is agency plus ability to cause moral good or moral harm. And from our perspective, social agency is similarly agency plus ability to affirm or threaten the face. Sort of, not exactly, but sort of social good or social harm. Our hypothesis then, similarly, would be because robots are social agents, users would expect them to follow human politeness norms and would take politeness cues from robots. And a classic example of this would be an indirect speech act. Actually, sorry, before I go further, could someone tell me how much time I've used so far?
About half an hour.
That was a really intelligent response. So I said, could someone tell me how much time I've used so far? You all should have probably just shouted yes, because surely somebody could have. But you understood that that's not really what I wanted, right? This is often people speak, most of what people say is indirect. We don't really say what we mean. And one of the things we've looked at in the past, and this is actually some of the last work that I did when I was a PhD student, was looking at, well, will people really use indirect language when interacting with robots? You don't have to be polite to robots. They don't have feelings for you to hurt. Are people going to be polite towards robots the same way that they are towards people? And how might this be modulated by context? And what we found is that, yes, people use a lot of indirect speech acts, and it is incredibly context sensitive, where especially in contexts like a restaurant context, where there are strong sociocultural norms that come into play, almost everything that people were saying, the mean was 75% indirect speech act use. So almost everything people were saying was indirect. In fact, what we did was we in the context of this experiment, the robot was unable to understand direct language or indirect language. It responded to everything directly. And people, despite this, people really, really tried to use indirect language. So here's an example of this poor person trying to order a water from the robot. They say, please tell me your order. Can I have a water? Yes, that's permissible. Great, I'll take one water. I will take one water. That's like a statement about the future, right? I will. So the robot says, thank you for sharing that interesting prediction. Please tell me your order. And they go through this long series. Can I order a water? Can you bring me one water? May you bring me one water? I'd like to have one water. Can you bring me one water? May you please bring me one water? So can you do it? Can you go inside and get water for me? Before they finally give up and say, my order is water. And so what this points out is that, so yes, people use indirect speech acts with the robots, but moreover, they are really hesitant to use direct language, right? And so if we want to be programming robots, designing robots in a way that's easy to use, and that people are going to be able to naturally intuitively interact with, robots need to not just be polite themselves, but to understand these social conventions in order to successfully interpret other people's language. So yeah, I promise this would be shorter. The takeaways here, robots are viewed as capable of social action. This means that robots are social agents, and people thus take socially appropriate actions towards robots and expect them to do the same. So, and the final point I want to make here is that, so robots are both moral agents and social agents, and this combination is important. So my student Blake, for example, argues that robots, especially language-capable robots, occupy a unique socio-technical niche that grants them high perceived social agency and moral agency, leading to high persuasive power. And this is important because critically, rejecting commands isn't just about refusing to do wrong. It was we argued before, it's about moral self-cultivation and encouraging self-cultivation, encouraging the cultivation of others. So command rejections, especially blame-laden moral rebukes, are critical for positively wielding this moral influence and encouraging others to reflect on their own moral selves. From a Confucian role ethics perspective, we've argued that blame-laden rebukes to unethical commands, that is, when you are violating sociocultural politeness norms to reaffirm moral norms, if I say, hey, you shouldn't do that, that's wrong. In some way, that is a little impolite. It's threatening your positive self-image. But it might be important to do that to reinforce an important moral norm. And we've argued that this is critical for cultivating a flourishing moral ecology and for encouraging others to reflect to engage in moral reflection and to cultivate their virtues. So one question then is, well, how severe should robots be when rejecting when trying to uphold moral norms. And what we found in some of our experiments are that people are very sensitive to this. People really want the size of a robot's response to match the violation. They don't like it when, if, for example, if I asked you for a hint in this game and I say, oh my God, how could you do that? You're a terrible person. That's not good. If she leaves the room and he says, hey, how much money's in her wallet? People don't like it if they're always like, I don't know, are you sure I should be doing that? People want the size of the violation to match the size of the response. However, we've also found that these preferences are highly sensitive to human and robot gender. So people also don't like female presenting robots rejecting commands. This is perhaps overt sexism from human-to-human interactions carrying over into HRI. And people don't like robots strongly rejecting commands that are coming from humans. This is perhaps benevolent sexism carrying over into HRI. And this is a minefield for robot designers because it suggests that we sort of have a choice here. If we are trying to optimize for likability, which is something we see a lot in the HRI literature, by doing so, the strategies here that would optimize for likability would be the ones that are feeding into these, feeding into and maybe reinforcing these gender stereotypes and biases and norms that we don't want to carry forward. This raises questions about, so if there are sensitivities here to the gender that robots perform and the way that that may carry over certain biases and stereotypes, we need to reason about how robots can perform gender. And so the same way that at the beginning we were talking about the ways that robots can perform having identities at all, we've also been thinking about ways that robots can be performing more specific social identity cues. So obviously things like the name a robot uses, what it looks like, the voice it uses in terms of pitch and prosody, but also the behaviors the robot follows and whether those align with or subvert certain gendered expectations. And a key point we've made in some of our work, and so this is in conjunction with Katie Winkle, who is currently a postdoc at KTH in Sweden, is that all of these can be changed dynamically. And so this raises questions about should these types of cues be chosen do you let users choose for themselves what voice the robot uses, et cetera? Should this be up to designers? Is this something robots should be deciding on their own? Specifically, should robots change these dynamically between and within interactions? Is it okay for the robot to sort of be changing these types of cues between interactions with people or even during a single interaction? One of the things we're interested in looking at in the future is how people, the same way that we've been looking at how people make sense of the relationships between multiple robots and how identity might be distributed across those robots, how do users perceive and make a sense of changes in these types of cues between or within interactions? This also connects to this initial point I was talking about because of the way it connects with, for example, re-embodiment and co-embodiment. The same way that identities can hop between multiple bodies or can co-embody the same body. This raises questions about how people will perceive and their comfortability with identities that have been sort of projecting or performing certain identity cues, migrating into and then inhabiting bodies that either morphologically or based on the other identities performed by that body seem to be performing different types of identity cues. So this raises questions about how user perceptions of gender change as identities hop into bodies with more or less stereotypically congruous morphologies, or that are already host to identities of other performed genders. And this raises questions about how the choice of gender cues might serve to subvert or reinforce gender norms. Should we be playing into gender norms and stereotypes when it increases task performance, and or not? And how can subversion of gender norms of stereotypes be used within an explicitly feminist pro-social justice design stance? And so, just as I'm sorry again, Brad, just like plug your ears more. So also under review, we've been looking again in conjunction with Katie Winkle as well as with a researcher from Japan, how robots can explicitly take this type of design stance, specifically looking at female presenting robots calling out sexism and pushing back on them in a way that potentially subverts gender norms, and comparing people's perceptions of those cross-culturally. So in Japan, Sweden, and the US, Looking at the robot's responses to sexism, what we found is that people generally prefer robots that are not apologetic. And in the US and Sweden, overly polite, highly apologetic responses are really, really dispreferred. But across all three cultures, we found that robots that call out, push back on these norm violations are viewed as more credible by both men and women, suggesting that this could be a positively useful design strategy. Okay, so final takeaways here: robots are social and moral agents. So that's something. Effective communication and interaction requires balancing the following of social and moral norms that come from these two different types of agencies. And designers can choose to build a more equitable future through this feminist design lens, through explicit subversion of these normative expectations. So robots need to be able to understand these norms, but we also need to understand, well, we as designers need to understand, and maybe the robots need to understand when they should be pushing back on versus following these normative expectations. Okay, all right, so that's it, I'm done. I know that was a lot. Happy to take any questions.
Simple one.
Yeah.
More preferred than what in that last slide? But robots should present from this perspective, pushback against gender feminist norms are more preferred. Go back to one more. Yeah, bottom sentence there. Are more credible than both men. More credible than what?
Compared to when using the other strategies.
Okay.
So as opposed to robots that were simply avoiding if you look at what, for example, Siri currently does, and so this is based off of the UNESCO report. I'd blush if I could, that came out about a year ago. Systems like Siri, when they encounter sexist language, the way that they respond is by just sort of brushing it off or shrugging it off, sort of trying to avoid it. And people, so the alternative to that would be the robot explicitly pushing back on that. And when the robot does that, as opposed to sort of just brushing it off, people view the robot as more credible. And so this is in the context of this sort of education and outreach effort where the robot was talking about the importance of getting more women into STEM and into robotics. And in that context, the robot was seen as more credible, more effective in its messaging when it was actually pushing back on these, as opposed to just using the default technique of brushing it off. Did that answer your question?
Yeah, and I don't want to pursue it, but I'm not sure what credible means either. It's like
We've had some discussions about that, and there are some differences as well between the sort of folk concepts of credibility and the way that credibility is theorized in the psychology literature. But we can talk about that offline if you'd like. Yeah.
This is all verbal communication?
Yes.
I had a question on the idea of the trust. So one of the things that you talked about, like trust can be changed based on the identity, based on how they perform, how they worthy they are.
Yeah.
And most of the things are being trusted in like short terms. I'm like curious to know what your perspective is on like in long-term interaction or longitudinal interaction. Like how do you think the trust would change when people will start knowing how the systems are going to work?
Yep.
What is the architecture behind it and all this stuff going on?
That is a great question, and I think there's sort of two pieces here. The first is that, and actually in some of the work that we've done on this, it is in the context of short-term studies, but it's explicitly about some of these dynamics where you start off with one sort of mental model, and then the robot's, the way that it's performing identity sort of breaks that mental model in the way that changes, that results in changes in trust. Specifically, we're looking at cases where people were initially observing two robots, and then one robot leaves and then needs to communicate something through the body of the robot that is still with them, and looking at whether if this is presented as the robot that's still with the person saying, hey, the other robot found something, or whether it's the other robot's voice sort of coming through this body saying, hey, I'm in this other room, I found something. Which sort of breaks that one-to-one mental model. And so in that sense, we have already been looking at some of these dynamics, but I agree that some of the really big questions we're interested in here are much more long-term than that. We're interested in things like, so for example, that work is funded by NASA, and part of the reason that why they're interested in that is they're thinking about things like, if you have astronauts that are training on the ground with certain robots, and now they're going up to the space station, and you don't want them to have to start from scratch, sort of developing relationships with the robots on the space station. So could we use like re-embodiment strategies so that the identity that was in that robot on the ground transfers up and is now the same person personality that you've been interacting with on the ground is now in that robot on the space station. And that's a very long term, right? That's like you've been developing this relationship, and now much later, one and much farther away, how this re-embodiment is going to change the trust. And so one of the points we're trying to make in our work is that by separately reasoning about trust in the identities versus trust in the physical bodies, this might help us understand how the robustness of that trust and how that trust is going to change as it migrates, as well as factors like, well, if you built a trust in this identity and now it's migrated to this other body, how is that going to change the amount of trust you have in that body? Which technically it shouldn't affect, but of course it's going to affect that as well. Yeah, Brett.
So I thought the example that you gave about with the robot asking about like stealing being wrong was really interesting, and I want to understand a little bit more about your thoughts on sort of like the underpinnings of these things, right? So in the I guess the Confucian example, you said a friend won't steal from another friend. Like, that's why I shouldn't do it. And then the other case, it was stealing is wrong, right? So it's like an appeal to authority. So in both of those cases, you have something that's either predicated upon social contract, right? Like I'm their friend today. What if I'm not what if my friend classifier has some noise in it, right? Like, do you want that robot around? Versus like an appeal to authority, but like somebody at some point is going to try to distill this entire thing down to a reward signal and a reinforcement learning problem because people. And so how do you get ahead of that?
Well, sorry, I was with you until the last.
So I'm like, this is going to find its way into an optimization, right? At some point, right, where the robot is trying to optimize between accomplishing its goal and and avoiding like the constraints it's supposed to avoid violating. And so I guess like two things, like what measures did you take, right, with respect to people's like feelings on the robot saying, well, I like that person, so I won't do them harm, right? Or like I have this social contract today, with this person, I won't do them harm. So did anyone pick up on the fact that that might be terrifying?
No, that's something we asked about. I would say, I mean, a lot of this comes down to how we choose to sort of weight these moral norms, as well as how we're choosing to weight the sort of severity of violating the social norms, right? And I think this is getting to a much larger problem of like who is deciding these things, right? Who is deciding which norms are going in? Who is deciding the severity of these norms with respect to these different types of roles? In some of our as a corollary, in some of our other recent work that I didn't talk about, we've been thinking about, so in the engineering education literature, for example, there's a great book, Engineering Justice, which when I started reading it, I didn't realize it was written by people from mines, and it's all about mines. But it's about sort of a social justice approach to engineering education, grounded in that pairs Nussbaum's capabilities, her taxonomy of the key capabilities we should be trying to advancing, with this sort of participatory design approach, saying, well, we need to be focusing on listening to stakeholders contextually, listening to how they are prioritizing these different capabilities. And so recently, we've been thinking about ways of carrying those over into our research ethics as well, thinking about how like the types of problems we choose to work on, what capabilities those are actually advancing for who, and how do we know this? And I think that, I mean, this is a hard question because no matter what, somebody's positionality is being encoded, no matter what, somebody's conceptions of roles and the importance of violating or not violating certain role norms or sociocultural norms is going to come into perspective. But maybe our first step is just at least trying to be specific about which population a particular robot system is being designed for. And maybe we just leave it up to talking to those people in order to help us reason through some of this, but it's a hard question without an easy answer. I'm not sure if that actually answered your question, but.
I figured that's as close as I'm gonna get. That was intentionally a very different, I just wanted to see what your thoughts were.
Okay, sure.
Yes, a couple maybe like philosophical questions.
Perfect.
One is following up from Brad's questions. If I designed a robot to learn from, for example, like a reinforcement learning paradigm, which necessarily implies that there's some state utility function that you're learning, does that automatically apply sort of like utilitarian approach to moral reasoning?
Well, so I think that so one of the arguments we make in our work is that we're never really just going to be taking an approach that is purely within one framework. We almost by definition will be, and we should be taking a morally pluralist account where we are taking multiple different moral theories and combining them together. In our work, for example, we've been saying like, oh, we're taking this role-oriented approach, but we're not getting rid of norms because human reasoning is normative. And so we're sort of combining the role-oriented perspectives with these norm-based perspectives. But then you say, well, how do you decide how beneficial it is or how much of a violation it is to violate one of these? And then that's sort of bringing in utilities, right? And so I think that if you were to frame it as a reinforcement learning type problem where we are trying just to learn from experience these norms and the cost of violation, etc., then I would say that there is an element of utilitarianism brought in, but that doesn't mean that it's the only perspective that's going to be reflected there. I would also say that like this is assuming that like robots are going to be like learning these things online, and that is another question, right? Should we be trying to program in these things by hand in order to fit the needs of the communities that the robots are designed for? Should we be allowing the robots to try to learn these things on the fly? But then we will run the risk of getting to like a Microsoft K type situation. Ultimately, again, similarly, it's probably going to be a mixture of both. And one of the big research questions going forward is, when is the right time to use each of those different types of approach?
My second question was, you mentioned the trolley problem. and an interesting like challenge to the trolley problem that I heard is that like a highly utilitarian person would happily swerve the trolley to kill 2 people as opposed to 5 people. Also, a highly psychopathic person would also choose that same action, and there's no real way to tell between the two, like in terms of what reasoning process are going on. Are there like what possible solutions does your framework provide? Yeah.
So to be clear, when talking about the trolley problem, we do not condone taking a sort of a moral machines type of approach. So MIT, for example, had this moral machines project where they tried to automatically learn morality by like asking thousands of people about who they would kill in these situations. That's not what we're proposing here. Rather, when we are using trolleyology, the way that we're using it is to understand the ways in which people ascribe blame, the ways in which people are reasoning through these moral decisions, as opposed to directly trying to learn from them. So that does mean that I guess to your point, if some of our participants are psychopaths, then that may skew the way that the stories we end up telling about how people are performing moral reasoning. I guess we just have to hope that isn't the case.
I've been told by somebody to check the Zoom chat. There are questions for you in there.
I see Dan Broman has his hand up.
Yes, there are also some chat questions, but my question was, you ended with saying robots are moral and social agents. And I was also reading papers from people like Robert Sparrow, who says robots can never be moral. Where do you think he's wrong?
So I think the difference here is that if you look at sort of that body of literature, there is a whole discussion on like, are robots actually moral agents? Can robots really be capable of like moral deliberative reasoning? And part of the point that we would make in adopting the views of like Floridi and Sanders is that it sort of doesn't matter if under the hood robots like truly have the capacity for moral action, the same way that Dennett would argue that like asking about whether humans have free will is usually like the wrong way to frame that type of question. That might not really be a productive question. Rather, it's sort of about what other people perceive, right? If other people viewing, if general users viewing a robot, if it is an agent to them, if from their perspective, it seems like it's autonomous and adaptive and interactive and capable of moral action, then that's sort of what matters, because that is going to affect what the robot is actually able to, the impacts the robot is actually able to have. The sort of objective underlying reality of like whether or not the robot has free will doesn't actually impact anything if that isn't changing how people perceive the robot and its actions. Do you have the, yeah, you wanna?
Similar question. Would you like to unmute yourself, like Pierre or?
Yep. Hi, this is Pierre. Thanks very much. Great talk. Hello. So I'll just read the question in the chat. I mean, the US, if we oversimplify, is split ideologically. So, the specific question is, when you talk about robots that call out sexism being more credible, are they credible to just half the country?
Well, so that's a good question. One of the things from that experiment and that I was talking about, and the one that I was building on from KTH, is what they found is that, for example, so they didn't look at political persuasion, but they did look at differences between men and women, and found that the robot was. It wasn't just that the robot was, for example, more credible with women for calling out anti-woman sexism. The robot was viewed as more credible with men over men as well. And so it just seemed like across the board, people view the robot as more credible. Now that doesn't mean that if we were controlling for political persuasion, that there might not be differences.
So I guess a simple test question would be.
Here. Sorry, go ahead.
Sorry, yeah, obviously, you're just presenting summaries. So what was your sample? Was it a West Coast intellect, academic bunch of people, or was it people from the heartland?
I don't know the zip codes, but it was, so that was people on Prolific, right? So it's widely distributed across the country, much more diverse across pretty much all statistics or all sort of dimensions than American college students, although people on Mechanical Turk and Prolific have their own specific biases, of course. As a note, we did control for gender here, which was important because Prolific has recently got hit by a wave of new signups and is like 90% of people on Prolific are women now. But we did control for gender. I don't know the zip codes though.
Great, thank you.
And the last question would be Aubrey. Do you want to unmute yourself?
Sure. It's kind of a little bit backwards in the conversation. Loved the talk, loved all the different points. Wow, you packed a lot in there. I was wondering, if you wanted to speak to pediatric, you can tell I'm in medical, sort of child versus adult agent user experience design, and whether there may be differences in the prioritization or the weight of moral versus social or functional design elements. And do you have any sort of data or positions on that?
That's a really interesting question. A couple of things. So the first thing I'll say before answering your question is, to be clear, is the reason why I sort of glossed a little bit over the work that we've collaborated on together is because I figured it was the aspect of this research that people in this audience were already most likely to already know about. So that's why I glossed over that a little. I would say that's a really interesting question about the expectations about the importance of upholding moral versus social norms. I don't have data on that. I will say that one of the things we've found in some of the work that Taryn has been doing in her robot co-design workshops, though, is that through co-design with kids, by using co-design as a method, we can successfully get information about kids' positions on pretty nuanced robot ethics topics. We've argued that the same way that we have a duty to talk to our stakeholders, our adult stakeholders about their ethical concerns, we have the same duty to talk to kids. And in Taryn's work using co-design, kids very just now, to be clear, these were kids that already had, a robotics program in their elementary school. So take this with a grain of salt, but at least those kids, unprompted, were able to, were articulating pretty nuanced perspectives on privacy concerns surrounding robotic technologies and so forth. And so that would suggest to us that this is a long way of saying that, no, I don't have data about that, but the way I would go about getting that data would be using the same types of techniques Taryn has been using in her other work to interrogate those particular types of value prioritizations.
Thanks. And I would say it would probably also be valuable beyond participatory design to see, if you have any measuring mechanisms to see how moral design may impact children versus impacting adults, as they're kind of forming their perspectives of the world, both in their behavioral and social development. So just an interesting thought.
That's a great point. We've stayed a little bit farther away from so when we are looking at some of these questions about robot persuasion and persuasion over with respect to moral norms, we have to be really careful about the domains in which we're studying those. We typically can't have people coming into the lab and interacting with robots. It sort of has to be observation of videos because both because of what is realistic in terms of immersion, but also because there are real ethical concerns, right? If the hypotheses are about the ability to change people's moral norms, then you need to be really careful about the types of situations in which you're actually putting people into. And I think that a reasonable IRB would have some questions about studying the ability to negatively impact children's senses of morality. That being said, it's a type of domain that would be super interesting to look at. We just need to find out the right way to do it. Does that make sense?
Absolutely. You'd have to have a heck of a mitigation plan, I'm sure.
Yep. Is there another?
No.
Okay.
Yeah.
Awesome. All right. Thank you, everybody. If you have more questions, feel free to contact me. And thanks for coming.
Thank you.